80% of the sun's light bounces off the clouds that blanket the planet. But even in the clouds, Venus, our so-called twin planet, manages to show an evil nature.
And we know that the clouds of Venus are made out of sulfuric acid, basically like battery acid. And that sulfuric acid is made by sulfur dioxide coming out of volcanoes on the surface.
Like its greenhouse cousin, carbon dioxide, or CO2, gas pressure pushes sulfur dioxide to the surface through volcanic vents. It's the same gas chemist Jeff Sutton monitors carefully at Hawaii's Kilauea volcano.
The gases, the sulfur dioxide in particular, is the noxious, toxic gas. And we wear gas masks to protect our lungs and our airway because sulfur dioxide combines with moisture in your nose and throat and forms sulfuric acid.
Sulfuric acid is nasty stuff. You don't want to splash battery acid on you. You know, you're careful not to do that. It's basically the same stuff. So it would not be good to suddenly stick your hand into the Venus clouds.
So if a traveler to Venus could survive the acidic clouds, the lightning bolts, the toxic air, and the heat, just how would the Venusian surface look? Volcanologist Jeff Burns with the United States Geological Survey, or USGS, circles the globe to understand what drives volcanic activity on the inner planets. When Burns imagines the surface of Venus, he considers the dark, eerie wasteland of Kilauea's lava fields on the big island of Hawaii.
It's very instructive to be able to come here and study this volcano to compare it to volcanism that has occurred on the surface of Venus. We can actually come out here to the field and study things. We can actually take samples and look at them in detail.
Geologists expect the amount of volcanoes on Venus far outnumbers the 1,500 or so on Earth.
Some estimates range from 100,000 to over 1 million volcanic features on Venus.
With that many volcanoes, lava rock makes up 70% of the Venusian surface, just like it makes up much of Kilauea's terrain. The ground becomes solid when the lava cools into hard rock.
Having a rock on Earth is our best analog for trying to understand rocks on the other planets. Basaltic rocks are the most similar to the Venusian plains.
Basalt is the most common type of lava rock found on Venus and throughout the inner solar system. The minerals freeze into glass and small crystals, a total transformation from what lava looks like when it streams out of the volcano.
When lava is actively flowing across the surface, it's incandescent and typically looks red. Now, quickly it'll form a silvery sheen over the top of it, and then over a period of a few weeks will turn black, such as the lava we see around me here.
At 5 miles high, Mont Mons is the largest volcano on Venus. And it's left some tremendous lava channels in its wake, just like Kilauea did.
Now, as you can see, the structure, we have levees here on the sides, and then internal structures as well. This is similar, perhaps, to how large channels called canali formed on the surface of Venus. However, they formed at a much larger scale.
Large enough to create seemingly endless miles of canali across the Venusian landscape. Consistent in both width and depth, the canali are much longer on Venus than on Hawaii because of environmental conditions on the planet. The dense atmosphere and hot temperature slows the magma from cooling into solid rock. And with little wind and no rain to further cool the magma, lava can cut through the surface for months after an eruption before it hardens.
On Venus, if you did see layering, you would expect to see layer after layer of volcanic rock that would all be relatively black and basaltic in composition. You would probably see little bits of color due to potentially oxidized iron, which would look red. Typically, basaltic lava flows are glassy enough that, in fact, you would actually cut your hand. They can be extremely sharp. They tend to quench and form glass.
And then there are the skies. That heavy Venusian cloud cover diffuses most of the direct sunlight.
So it would be a lot darker on the surface of Venus during the day than it would be here on Earth. Also, because the light is scattered very efficiently, you tend to lose shadows. So everything is lit fairly consistently across the surface. And then additionally, because of the composition of the atmosphere, everything would tend to have more of an orangish tinge to it.
Natural wonders. But how would the Venusian terrain measure up against another geologic feature, our canyons? The Grand Canyon, a great chasm eroded over 250 million years by the Colorado River.
When the energy to cut back through the canyon and wear away the rocks.
The vast canyons on Venus may have also been formed by erosion, but not by a river.